Hi, welcome everyone to our new tutorial. Today we are discussing on the principal factor analysis approach in RStudio. And so let's go to its functions. This method is helpful in reducing the dimension of the data while keeping its explaining power. So it means that if you have 10 variables in your analysis, and it means there are 10 dimensions. So more dimension means more complications, more difficult to handle the data. So this function, what does it do? That it reduces the number of variables to a lower number, and it makes sure that the power of the 10 variables is not reduced. Secondly, in a regression analysis, this method is helpful in reducing the proposed independent variables. Unlike stepwise regression, it performs well when your independent variables have high multicollinearity. So in a conventional stepwise regression, it reduces the variables which are insignificant and keeps the variable which are significant. But if the independent variables which are significant are collinear, it will not perform well. So this function is useful. So today we'll go towards RStudio and work on this function. So for this, there are a few libraries that are required. So it's read Excel for reading Excel files, tidyverse for data management, core plot for correlation plots, qgraph is for the loading graphs, and it can also be used for correlation graphs. So PSYS is for rotated factor analysis. Plier is for data management, means you need to join 2 or 3 files, and dplyr is also a bigger function to do the data management. Plastics is for descriptive analysis. So when we highlight it all and do control enter, so it will load all the libraries that are required. So all the libraries are being loaded. Okay, so after that there are two more functions that are needed, but the library commands are there. So these are gg byplot, okay, and gg screeplot. So usually it gives error in few computers. So rather than downloading, I am just connecting it to a source. So if internet is connected, you can open the library via internet. So this library was not loading in my computer. So what I did, that I used this command and learned it from internet, and then when I load it, so that libraries, the codes of the library will be loaded as a function. So it will not give any error. Okay, so but if you can try these like commands, so you can install, then you don't need these import functions. So I have a data file, it's for the sales of a car. Let us load, and then I will show you. So this data file, so it includes the determinants of sales. So this is sale data, how many, and this is a type of car manufacturer, car model, sales, its price, and its other characteristics. So our intentions are to make a model of determinants of a sale of a car. So but since we have too many variables, so if we use regression analysis on all the variables, it is expected that it will lead to multicollinearity. So what we will do, we will try to reduce the number of variables. First of all, we'll summarize the data. So this command summary.sales give you brief summary. It gives you first quintile, minimum, median, maximum, third quintile, and maximum. So this is a minimal data descriptives, but if you need more, that's stat.describe, and sales, if you go here, so you will have details. So it gives you a number of data observations, number of null, number of NAs, minimum, maximum, range, sum, median, mean, standard error, confidence interval, and variance, and standard deviation, coefficient of variance. So all the things that you need in a journal research work. First, then for the factor analysis, we need to remove the missing values. So that is sales is equal to drop.na sales. So when I run it, it will make a new data file which has fewer observations. It has removed like 40 observations, so that data is now. Now we will do the correlation plot, that is core plot, and I'm selecting a column from 66 to 14. So in my here column 6 is, you can see here, so it is fifth, 6 from type to 14, so it's 8 variables. So it's 11, 12, 13, so up till here, so it's 13, 14 variables. So from 6 to 14, so these are 9 variables. So when I press Ctrl Z, it will make a graph. So you can see that the dark blue colors are prominent. So these are dark blue colors other than the diagonal, these. So they show that there's a hint of high correlation between the variable, this dot. So this is giving us hinting that there is a high multicollinearity. We can also confirm it using the Q graph. So when I run it, it gives us the correlations. So the darker the color means higher correlation. So this way you can check for. But if you use another method, that is the rectangle method, what it will do is that it will show the graph based upon the distance between the boxes shows the correlation. So these two are very near means high correlation. These two are very near, high correlation. So these two are very far, very low correlation, very low correlation, high correlation. So this way you can geographically plot a graph so that you can see the correlations. Now what we'll do is we'll start with the principal component analysis. So PCA is equal to principal component analysis, sales from 6 to 14 variables, and we do the correlation. So it will do the analysis and store in PCA. Now what we can do is we can see the so since there are 9 variables, so this method will propose 9 components. So these are 9 component variables. Okay, now let's go forward and I will show you. So you can store these components in DF PCA scores. Okay, then if you summarize it, so it will give you the proportion of variance. So 0.92 is highest. So first component is 92% significant and is explaining 92% variation in the data, and remaining 8 are explaining 8%. So it means only one variable is enough to explain all of the 9 variables up to now. So what we can do is then we can do its loading plots. So here you can see which variable is correlated with which one. So type is correlated with component 8, price is correlated with component 3, engine size is correlated with component 7. So we select with which has the highest correlation. Horsepower is correlated with component 1, and wheelbase is with component 4. So this way you can see the correlation. Then the remaining part we can see using the graph. So now we plot the PCA. So you can see that only 1, 2 and 3 components are above this red dotted line, because the first one is too big. That's why the red dotted line is so low. So this means there are 3 factors that can be used rather than using 9. So it means rather than using 9 variables, if you use 3 with this method as proposed, it will give same results, or it will have same power to explain the dependent variable. So your model will be like simple, because 6 variables have been reduced and it have same power as the 9 variables. So we can plot this again using this plot command, these 3 lines. So here you can see first 3 components are above this dotted line, others are below it. So this dotted line is this red line is on 1. So 1 is a threshold. So we can also use this GG plot. It uses the eigenvalue method. So only only 3 are above the 0, others are very low. So we can select first 3. Similarly, other commands will give you similar things. So this command will provide you the components. So this shows that the first 3 are outside the first 3 are significantly outside this cutoff line. So and they have the variation explained near to 1, others are less than 1. So we can select 3. Then we can now, since we have 3 components, so what we can do is we can plot a biplot. And what you can do is, so it can plot between 2 components. So let's zoom it up so that I can explain you what is how to interpret the biplot. So biplot is actually a scatter plot of 2 components that are generated from factor analysis, and then it plots the independent variables with using these lines. So these length and wheelbase are similar to comp, so they are correlated with this variable. Horsepower and price is more correlated with component 1, so it's correlated with component 1. So it shows you which variables are located in which component, so you can categorize them using this approach. Next is, so you can make ggplot method. It is more readable. So what it has done is it's using standardized PCA. So it has horsepower is correlated with PCA1, and you have to zoom it out so that you can read how they are performing. So in your, if you add higher pixels and then you store it in the Word, you can zoom it in and you can see what the names of these variables. So if they are vertical, means it is correlated with the PC2. If they are horizontal, then PC1. If they are diagonal, it means it's correlated with both. Okay. Now we can do the same thing without rotation. So we can make the core plot of the factors. So it has proposed three factors, and the correlations are there. So first factor is correlated with this variable, horsepower, and factor 2 is correlated with price, and factor 3 is correlated with length. So this way we can find out which three important variables are needed. So but we need to do rotation. So I will do the rotation, and then this RPCA test. So you can see the RPCA rotated principal component analysis. So it has proposed three components and its correlation with the variables. So you can find out that wheelbase is the first component, and then price and horsepower are almost equal. Then, and for third it is type of a car. So this way you can, and then there is a test for components are sufficient. So it is test for hypothesis that three components are sufficient, and it is significant. It is insignificant, so it means that they are sufficient. Okay, then we go towards its summary. So you do summarize. It will give you the test for so three components are sufficient. It provides a test, and test is significant. So it gives you that the components are sufficient. Okay, so this is a different test. So chi-square it is significant. Then we can do a biplot for this component. So because there are three components, so we cannot make a single biplot graph. So what it is doing is this is comparing all three together. So this is a very useful graph. So distribution of three components, and then look at for component 1 and 2 how the variables are correlated. So you can note that the three components that we are made, all the variables are on a 45-degree line, most of them. Like the only few are here which are spanned out, and few are here, but majority are on the 45. It means that the three components are actually correlated with all of the variables. So it means these three are able to explain all the variables which are used in the data. So it means you can rather than using 9 variables, you can go to 6 variables. It will help you to reduce the complexity in the model. So then you can plot these. So let's plot. So this Q graph will plot you correlation with C. So for 1 is this 3 are relevant, for 2 is this one is relevant. So this way you can have a rotated loading. Then you can make it a different way like this. So it will give you a view of how they are related. So this way you can do the factor analysis on using RStudio. If you want to store this data, so the command is already shown here, that is df2 PCA scores. So in df2 you will have all the factors. Now you will need only first 3 to be used as an independent variable, and the dependent variable is the sales of a car. So hopefully you understood the factor analysis. The commands of this will be shared you in the below the video. Hopefully you will be able to do this process on RStudio for your projects. Thank you very much.